The pupillary light reflex is a great example of how the parasympathetic and sympathetic divisions of the autonomic nervous system interact. What I've drawn here is an eyeball, which I'm just now realizing has an awfully close resemblance to the Eye of Sauron, for all you Lord of the Rings fans out there. But anyways, we've got the iris, and then we have the pupil, which is the hole in the iris that lets light in. And then we also have the sclera, the whites of the eye, that contain a lot of elastic fibers and collagen that protect the eyeball. But what we are going to focus on is the iris. And I've drawn in two different colors the two different types of iris muscles that control the size of the pupil and in turn how much light is getting in through to the retina in the back of the eye. In green are the circular muscles. And in purple we have the radial muscles. Now, these complement each other because when one set of muscles contract, the other relaxes. And depending on which of the two types of muscles is contracting, you have different amounts of light coming in. So if the circular muscles contract, the pupil gets smaller, as shown in the diagram in the left-hand corner. So when the pupil gets smaller, only a little bit of light is able to get in. And this is called pupil constriction. Now, if the radial muscles contract, the pupil gets bigger and lets a lot of light in. So these are rays of light coming in. And this is called pupil dilation. Now, why is this important, you might ask? Well, say you're an antelope, it's in the middle of the night, and you would really like to make sure that you see that lion sneaking up on you in the grass. To do that, you want to let in as much light as possible. So the situation in the right-hand corner, pupil dilation really is preferred in dark settings. On the other hand, if it's in the middle of the day and you have excessive light flooding in and you want to protect your retina from excessive illumination by limiting the amount of light that's coming in through the pupil. So light settings favor pupil constriction, which you see on the left. So what controls pupil dilation and constriction? The autonomic nervous system, specifically the sympathetic and parasympathetic nerves. Now, given what we've discussed, my question for you is this: which type of nerve innervates which muscle type? Now, I'll give you a few seconds to think about that, and as you think, remember the antelope and consider which subdivision of the ANS, parasympathetic or sympathetic, is more active in a dark, stressful environment. So hopefully you all said that the sympathetic division, responsible for the fight or flight response, innervates the radial muscles. Oops. Wrong color there. So sympathetic activity is increased during stressful situations, causing the radial muscles to contract, leading to pupil dilation, letting more light in. On the other hand, parasympathetic innervations are responsible for pupil constriction? Because parasympathetic activity increases in light settings or non-stressful situations, causing the circular muscles to contract and less light to come in. Now both nerve types release neurotransmitters to cause muscle contraction. Parasympathetic nerves release acetylcholine, which binds to receptors on the muscle and causes a cascade of effects that we won't get into now, but essentially leads to contraction. And then the sympathetic nerves release another neurotransmitter called norepinephrine, also known as adrenaline, to elicit muscle contraction. Now my final question to you, and you'll have to think back to the first video, are these nerve fibers that cause contraction in the circular and radial muscles afferent or efferent? So think about what's happening here. So light is coming in from the environment, hits the retina, travels along the optic nerve, and reaches the CNS. The signal is processed, and motor signals causing contraction in either the circular muscles or radial muscles, depending on the level of light, are exiting the CNS to the periphery. And what did we say about exiting fibers? EE, exiting efferent. Got it? Okay, so to bring it back to the top, the level of light in the environment dictates the level of parasympathetic and sympathetic activities, which in turn control the size of the pupil, whether that means constriction or dilation. And this reflex is just one of many activities made possible by the autonomic division of the peripheral nervous system.